Hi everybody, welcome to Unit 8, Lesson 3, Surface Area of Right Rectangular Prisms. So to think about like right rectangular prisms, one example that I like to use is like a cereal box. That's something that everybody can recognize and you might even have in your house right now. So for surface area, we're trying to think like if we were to cover that box in wrapping paper, right? Or even think of an Amazon box. I'm sure a lot of your parents probably order from Amazon, and then they also make great gift boxes too. So surface area is like if we were to cover the outside of that box with wrapping paper, what is the exact amount of wrapping paper that we would need in order to cover it? Okay, and so in your lesson, you're going to see pictures of three-dimensional figures, but then you're also going to see pictures of something called their net. Okay, so a three-dimensional shape's net is just the flattened out version. So like if you were to take that Amazon box and cut it to where you like lay everything flat, nothing was covering any other part of it, that would be the net. Okay? So there's two different formulas for surface area of rectangular prisms that we're going to be looking at. First off, there's surface area of a cube. So think about a cube. A cube is where all of the faces are the exact same and they're all square. So to find the area of one of the faces, you would do length times width, but those are the same length, right? So that's why we're able to just use one variable to represent the edge length, okay, and squared. So this is like length times width, or a times a, or a squared. And there are 6 faces, so we're able to take that area and multiply it by 6, and that will give us the surface area of the entire figure. Now, not every box is a perfect cube though, so we need to have a method in order to find the surface area of other shaped right rectangular prisms, and that's what this formula right here is. Okay, so we have the opposite sides, opposite lateral sides are identical, right? And those are still measured by like taking the length and the width of those, which can either be represented by width and length or the height of the box. And I'll try drawing a picture so you can kind of see what I mean by that a little better. But so let's go ahead and get into it. All right, my first example, it says calculate the surface area for a right rectangular prism with the following dimensions. So if they have different dimensions, which means it's not a cube. So we're going to, let's see, if I were to draw this, and this is not going to be perfect, but let's see here. Maybe that's my height. Okay, so I don't know. It gives us at least an idea of it, right? So the height is 8 inches, and that should be true. Like I put it right here for this one, but it would be true even if I put it here or back here. Like that doesn't really matter. The length is just, that's how long the box is, and the width, that's how wide it is. Okay, so those are our three dimensions. So for surface area, we have 2 times the width times the length plus the length times the height. Ooh, I didn't leave myself much room. Plus the height times the width. All right, and so I'm going to show you what that represents. I'm going to scoot over a little so I have more room. So 2 times width times length. Well, let me draw those so we can see. So width times length, that would be like this. Let me get another marker. That'd be like this. Here's my width times my length. Well, what that is doing is that's the area of the base of the box. And I have 2 of those, right? And that's why I'm multiplying it by 2. So I have the bottom of the box, but then I also have the top. So that takes care of those, right? So in this case, and I'll even color code it. That would be 12 times 18 plus, and then let's see, the next one, we've got length times height. Well, here's my my length, right? My length is here times my height. So that's like the right and the left side of the box. So that's that one, and that's this one over here, the left side. Okay, so that's those two dimensions. So let's see, that would be 18 times 8 plus, and then my final one, I gotta find a different color. Let's see, we'll do green. The final one is height times the width. So height, well, that's right here, right? There's my height times my width. That's this one back here. Okay, so that's the back of the box and the front of the box. So that's all 6 sides, right? Because there's 2 of them. So let's see, and that would be height was 8 and width was 12. So it's really just making sure that you have every single side accounted for, all right? So at this point, then we can go ahead and just solve, all right? And that's going to give us our surface area. Some of these numbers are a little bigger, and I don't feel like dealing with them, so let me get out my calculator. Okay, so let's see. First I have 12 times 18. That gives me 216, so I'm going to show every one of my steps. It's always a good habit to be in. So right here we have 216 plus, and then we have 18 times 8. Remember, we have to do the order of operations, so that multiplication comes before the addition, okay? And then 8 times 12 I know is 96. I know that one. Okay, so now that I took care of all of my multiplication within my parentheses, I'm going to add them together. So I have 216 plus 144 plus 96. That gives me 456. Okay, multiply that by 2, and I'm done. So in this particular case, let's see, and we had inches. Surface area, just like area, that's a 2-dimensional attribute. So our units are going to be squared. So the surface area of this figure, would be 912 inches squared. Okay, it looks all pretty with all those colors on it. All right, number 2. A roll of wrapping measures 25 inches by 405 inches. I probably meant to write paper on there, but I forgot. So, a roll of wrapping paper measures 25 inches by 405 inches. The boxes being wrapped are 16 inches by 14 inches by 6 inches. How many boxes can be wrapped? Ooh, there are several things going on here. All right, so first off, we need to find the total area of the wrapping paper, okay? Which that's just length times width. It's just one, like if you were to unroll it, it would just be one massive rectangle, right? So I'm going to take notes to make sure I get everything. So area of paper, or the wrapping paper, that's found by doing 25 times 405. So let's see here on, let me get the calculator again. 25 times 405, well, that gives me 10,125 inches squared. Okay, so that's that area. Next, we need to find the surface area of the box, right? So let's see here. I'm going to draw out the box like in the last one just to make sure that I have everything. Or actually, I don't even have to do that. I'm just going to label these. I'm going to say that my length is 16 inches, my width is 14 inches, and my height is 6 inches. And I can do that. I can decide which is which because especially when you consider multiplication, right? The commutative property, it doesn't matter what order we multiply them in, okay? So I can do that. And then we can say the surface area equals, and then I know it's 2 times, and then just to make sure I have each part, let's see, we've got width times length plus length times height plus height times width, okay? And that, remember, that's what's going to make sure that we have everything taken care of. All right, so let's go ahead and we're going to plug everything in here. So we've got 2 times and then 14 times 16, right? I'm taking these numbers here and I'm putting them into my formula. Plus, and then length times height, so that would be 16 times 6, plus, and then I have the height times the width, so that is 6 times 14. Okay, and then within my calculator, let's see, first I've got 14 times 16, that gives me 224, plus, and then 16 times 6 is 96, plus 14 times 6 is 84. Okay, then I'll add them all together. So 84 plus 96 plus 224 gives me 404. Multiplied by 2 gives me 808. Okay, so each box takes up 808 inches squared. So now what we need to do is we need to take the area of the paper, right? We're taking the area of the paper and we're breaking it up into equal sections of 808 inches squared. Well, when you do that, that's division, okay? So to solve the final problem, we're going to do 10,125 divided by 808. So on my calculator, let me see, we've got 10,125 divided by 808. That gives us 12.53, right? So you're not going to wrap 0.53 of a box, right? So for our final answer, in order to make it make sense in terms of the question, we would just say we could make 12 boxes, right? Or we could wrap 12 boxes. So that would be our final answer. We could wrap 12 boxes, okay? Which, like, if you own a company and you do gift wrapping for your customers or something like that, that could be really important. You don't want to be wasting wrapping paper, especially if you do it for free for customers, because then you're just wasting money, right? If you're wasting wrapping paper and buying more than you need, you don't want to do that. All right, this next one, this is number 5 from your quick check. A box needs to be decorated to use as a prop in a play. The bottom and back of the box don't need to be decorated. What is the surface area of the space that does need to be decorated? Okay, so for this one, we don't need the bottom and we don't need the back, right? So I still need to like keep track of everything though, right? So for this one, for my surface area, I need the front, I need the top, and I need the left side and the right side. Okay, right? I need the area of each of those, but we can ignore the back and we can ignore the bottom. All right, so that being said, we could find each of these individually if we want. So let's see, the front. Let me change my colors. Okay, here's my front, right? That is 20 inches high, right? 20 inches high times 27 across the bottom, right? So it's 27 by 20, all right? So that takes care of the front. Plus, and then let's see, the top, well, that looks like, let's see, that's 20. That's also 20 by 27. Okay, 20 by 27. So, oops, 20 times 27. And then the left and the right, they should be identical also. And maybe we could have already seen this, but it was still good to make sure that we have the right numbers. So for the left, ooh, look at that. It's a cube or a square right here, right? That's this guy. And here's the left, right? It's a 20 by 20, and that's on both of them. So 20 times 20 plus 20 times 20. Now we also could have just multiplied that by 2, right? Just like we did in the original formula. But at least this way we have it all written out. Okay? So let me go back to, we'll use purple. All right, so then we'll get handy dandy calculator. Let's see. With this I have 20 times 27. That gives me 540. Plus, and then there's another 20 by 27, so that's 540. Plus, and then 20 times 20, I can do that in my head, that's 400. Plus another 400. Well, I know those added together is 800. These added together are going to give me 1080, right? So I'll add that to make sure, and then plus 800 gives me 1880. And let's see, ooh, centimeters squared. I don't even know what this box would have been for a prop and a play, but it would be centimeters squared. Okay, and that would be it. So I tried to choose different types of problems from this lesson. I hope that helps, but as always, if you need more, just let me know.